The different populations of stars actually show us the effects of what we call the star-gas-star cycle. This is the process where stars form from the interstellar medium, they burn, and then they eventually die, sending that material back out into the interstellar medium. Here is our second lecture quiz question. Where do stars begin to form? A, in reflection nebula, B, in dark nebula, C, in emission nebula, or D, in H2 regions. Go ahead and think about it, and we'll discuss in just a bit. Alright, so where do stars begin to form? The answer is B, in a dark nebula. Dark nebulas are cold and dense. Because they have a high density, that means they have stronger gravity pulling everything in, and because they are cold, they have very low pressure. So in a dark nebula, we have gravity pulling in and not as much pressure pushing out, and that means pockets within it are going to be able to collapse and actually begin forming stars. So after the Big Bang, the only elements there were hydrogen and helium. We've mentioned this previously, and we'll explain why that is later on when we actually get to the Big Bang. So these pockets cooled off and condensed and formed into the very first stars. Now these stars evolved just as stars do by converting lighter elements into heavier elements through fusion all the way up until iron. Well, when these stars die, they're going to spread that material back out into the interstellar medium. So at the very beginning, there was only hydrogen and helium. After the first generation of stars, there's hydrogen and helium and a tiny little bit of metal. Then the next generation of stars is going to form from this interstellar medium that has a little bit of metal. So the interstellar medium cools, forms into dark nebula. Inside the dark nebula, we now form the next generation, which will be made of hydrogen and helium and a little bit of metal. Every time we go through this cycle, this means we're going to increase the amount of metals. So the very first generation of stars should have only hydrogen and helium. The next generation of stars should have hydrogen and helium and a little bit of metal. The next generation will have hydrogen and helium and a little bit more metals, and so on. So we're slowly processing, converting hydrogen and helium into heavier and heavier elements through fusion in stars. Now, each time we go through the cycle, we're actually going to lock away some of the interstellar medium into some kind of stellar remnant. White dwarfs, neutron stars, and black holes, all of that material is stuff that was a part of the interstellar medium before the star formed. And those things are not going back into the interstellar medium. So with every generation of stars, we actually use up some of the interstellar medium. Based off of the current star formation rate in our galaxy, there's going to be no new star formation in about 5 billion years. The interstellar medium is going to be used up to the point that it's no longer going to be able to collapse and actually form new stars in about 5 billion years. So we mentioned we have these different populations of stars. Population 1 stars are young and metal rich. Both of those suggest that those are a recent generation of stars. Population 2 stars are old and metal poor. Because they're older and have less metal, that means that they had to form before the current generation of stars. However, even population 2 stars, these ones that are old with very little metal to them, they still have some metal, which suggests there has to be at least one population before them. These are what we refer to as population 3 stars. Population 3 stars are the very first stars that should be just hydrogen and helium and nothing else. Now, if you remember back when we talked about how long stars last, low mass stars can actually last for tens to hundreds of billions of years and possibly even out to trillions of years. What that means is that if there were some very low mass stars that formed during this very first population of stars, they should still be around today. Now, one of the ongoing questions that we're still trying to figure out is, so why haven't we found any population 3 stars? This is something that we will talk about later on, but again, we're going to have to get to the conditions of the very early universe before we get into it.